not tomorrow. Sent that this morning. That quiz is only going to cover those exponential equations that I gave you back the other day. That answer sheet is there, and these kind. Now, there's a couple things I want to point out. Look at 25 and 26. Some of you messed these two up. What was the first step in every single one of those? Every single one that was on that page. Here, what was the first thing you had to do? Every single one. Ethan. No. What was the first step in every problem on page 676? I mean, look, here's 25 and 26. What was the first thing you had to do? Your first line of work, you had to write it down.
You put 1 over...
No. The very first step in every single one of those problems was to... You got your papers right there. You all did it. Look, what's the very first thing you had to do on these log equations? It had to be your first line. Had to be. Adam.
Change from logarithm to
Convert it to exponential form. This to this equals this. This to this equals this. Now, I looked at your papers. Some of you messed these up. What did I tell you to do on problems like this? As I showed you 2 days ago. I noticed some of you messed this up. So if this is you, pay attention here. How did I tell you to continue a problem like this? Howard.
Move the x to the denominator and cross multiply.
Yeah, remember? Above. Now, some of you in here messed this up. Then you can just go boom, 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 boom. So this would be what? 125x cubed equals 1. Divide by 125. So what's that make the answer there? If x cubed equals 1 over 125, what's x? Go ahead and take Dave. Take the cube root of both sides, and that'll be 1/5, right? This is 64, x to the 6 equals 1, so x to the 6 equals 1 over that. I know that's kind of a higher one, but it's perfect. What's the 6th root of 64? It is a perfect root. David?
1/2.
2 to the 4th is 16, so 2 to the 5th is 32, so 2 to the 6th is 64. So if you take the 6th root of both sides, you get that. Now, 31 and 32, look at the answer sheet. Just like those two, isn't it? See 31 and 32? Same deal. Now, oops. There's something wrong with that. What's wrong with that? You see it? There's one little thing wrong with that. Do you see it, somebody? That's not completely correct. You don't see it? There's one little thing wrong with that answer. Ethan.
Plus or minus.
Yeah, that should be
But
plus.
I also have a question.
Go
On
ahead.
the answer sheet, you put x equals plus or minus 2, not 1/2.
Wow.
Okay, I didn't know.
No, I apologize.
Okay.
It pains me to say it, but sorry about that. I made a mistake. Thank you for pointing that out, though.
Yeah.
Swipe. Now, who just said get a common base? Who was that? A few minutes ago, I said, what are you going to do? Somebody said get a common base. Who said that? You guys, this is Night of the Living Dead. This has got to change, man. This is all one-sided. Look at number 21 and 22. When the variable's in the exponent, that's when you get the common base. You don't always get a common base. In number 23 and 24, there's a fractional exponent you raise to the reciprocal power. Swipe to the second page there. Swipe to the second page. 33 is a common base problem. 34 is a common base. 36, 37, and 38, those radicals, you had to convert them first to powers. And then you finish the same way. Yep.
What about the A through E problem?
Hold on. Let me find this. A through E? Okay. Somebody, what was the answer to the A problem? You got it there? I didn't put it on the iPad. Let's just go through the answers. Joe?
16.
8, x equals 16. What was the answer to the B problem? You should have raised both sides to the 3/2.
350.
350, that's right. Now, if you have a question, I'll take it in a minute. What was the answer to the C problem? Rob?
27.
27. What was the answer to the D problem? Howard?
238.
Correct. And how about the E? Did you get this one? Look. That was the E problem. Raise both sides to the reciprocal. That's going to come right out for you, isn't it? What's the answer? It comes right out, don't it? Jimmy?
11.
11. Any question on those? Okay. Did I give you the papers? That's for everybody there. Okay, fellas, this is only gonna take about 15 minutes. All right, just put your iPad aside for now. This is only gonna take about 15, 20 minutes. Tomorrow, I'm not gonna be doing much tomorrow, I'll tell you that right now. Now you understand, the quiz is on Monday. It's on exponential equations and the homework I just gave you back. Okay, look what it says on the paper I just gave you. Read those directions to yourself. That's what I'm going to show you right now. Rewrite, use the properties of logarithms to rewrite each expression as a single logarithm. Now look, I'm going to keep this real simple. The homework you just turned in today, you were using those three properties and you just kept expanding it, right? Until you couldn't do it anymore. This is the exact reverse of what I did yesterday. The exact reverse. Look at the examples that are on that paper. You see what's on the paper there? Isn't that what all your answers looked like yesterday? Think about what I just said. See all them problems, examples there? All your answers from 5 to 15 looked like that. Now it says rewrite it so it's only one. So you're going to use them properties, but in the reverse. Why are you doing this? Because next week when we get back to school, Tuesday, I'm going to be going into other things where you're going to be using all this. So watch how fast this is going to be. Now, right on the handout. You have the log of 8 plus the log of 12. Now you're using the properties in reverse. It's the easiest way for me to say this. So if you have the sum of logs, where did it come from? If you like to say the step before. You're just going completely backwards. Adam.
That 8, 12 you're multiplying.
Yeah, this would be the log of the product to the same base. And if you can do anything to it, you would do it. So 8 times 12 is 96. That was easy. Now, every answer on that paper, now fill in the paper as we're going on. Every answer is going to be one logarithm. That's what the directions are saying, one single logarithm. All right, how about this one? These first 3 or 4 are going to be really fast. Here's the log of something, subtract the log of something. So what property was that? Do you understand? All you're doing is going backwards from what I did yesterday. No.
Log of 6 over x and 5.
The log of 6 divided by x to the base 5. And now every time when I do one of these, you know what I'm going to say? I says, can you do anything with that? Can you do anything to 6 over x to simplify it? No. That's done. These first few are simple. Now, what about this? When there was a number in front of the log, where did it come from? Just think of what you did yesterday, but it's in the complete reverse. The 4 log of m meant what? Where'd that 4 come from? When there's a number in front, where did it come from? Come on, we just did this yesterday. When there's a number in front, where did it come from? Rob? It was the exponent of that, right? So what does 4 log of m mean the same as, Jack? The log of? The log of m to the 4th to the base b minus the log of n to the base b. So what's the final answer? Now here's the log of something, subtract the log of something, just like that. What's the single logarithm? Come on, these are easy. What's the single with the log of this, subtract the log of this? What's the one single thing going to be there? Ethan?
M to the 4th over n to the base b.
The log of m to the 4th over n to the base b. Can you reduce m to the 4th over n? No. If you could, you would. That's done. Look at the checked answers. 1 logarithm, 1 logarithm, 1 logarithm. Look at this one on your paper. Now, these are getting a little bit more involved, but Adam, you have a question?
For number 3, yeah, can you go straight to the answer on test?
For this one, yeah, that would be okay. That would be okay, what he just said. Because you know this was, yeah, that would be okay. Now, some of these are going to get a little bit more involved. Now, what's this? What's these two first? Be careful here. You got the log of something plus the log of something. Where'd that come from? What'd that mean? Where did it come from? Joe?
Multiplied the numerator.
The log to the base b of what two things are going to be multiplied?
X plus 1 and, well, quantity x plus 1 times quantity 2x minus 1.
Now, just write this down the way I'm doing it. This times that minus, what's this? Whenever there's a number in front, just remember, where did that come from? So that you always want to take care of that right away. What's 2/3 log of x mean? Just use that power property backwards. What's it going to be? Somebody? What's it going to be? Andrew, what's that going to be right there?
Log of x to the 2/3 to base b.
Not done. Continue. What do you think I'm going to tell you to do here? Log of this, subtract the log of this. What do you think I'm going to tell you to do? Right there. Come on, use your common sense. Basic algebra, actually. Well, there you go. Isn't this going to be the log to the base b of this over this? Are you with me? Because it's subtract. But did you hear what he said? Binomial times binomial. FOIL. Somebody want to give me that? FOIL it out. Basic algebra. What's x plus 1? This is going to be a fraction. What's going to be on the top? Joe?
3x squared plus x.
How are you getting 3x squared?
Just 2x squared. 2x squared.
Go ahead.
Plus x minus 1.
Over what?
X to the 2/3.
There you go. Look at the checked answers. One single logarithm. How about number 5? That's an easy one. There's no work to show in number 5. Go directly to the answer. There's no work to show in number 5. The log of n plus 1 plus the log of n minus 1. What's it equal? 1 logarithm. Come on, it's very similar to this, but it's actually even easier. Michael.
These are first and last.
So this would be the log to the base 10. All right, now, here. Let me just write this down first. You can go right to this, but I just want you to see where I'm getting it. What is n plus 1 times n minus 1? Now, that's not even a full FOIL. Say that again, what you said.
N squared minus 1.
First and last is n squared minus 1. Done. Now, whoever that was said over here, can you go right to this? Look at number 6. I think you can just give me the answers. Well, here, I'm going to show you the first one. Here, give me the next line there. What do you do first? Because there's numbers in front again. When there's numbers in front, that means they were the exponent, right? So what's 2 log of x plus 3 log of y? Convert it over. Ethan.
Log of x squared to the base a plus log of y cubed to the base a.
So what's the final answer then? You got a sum of logs. Where did it come from? What's the final answer? Howard.
Log of x squared y cubed to the base a.
That's right. Done. What's this? Wait, does anyone have a question? I mean, this is pretty straightforward. You're just using the properties backwards. What's this? It's in parentheses, so take care of this first. What's this is 1? David?
Log of x over y to the base of b.
Plus, what's that? It's a number in front. Rob? Sorry.
No, you're good. Log z to the 4th base b.
Log of z to the 4th to the base b. Now be careful here. What's the answer? Ready to give it, aren't you? Sum of logs. Doesn't that mean you just multiply the two things? What's it going to be? What's x over y times z to the 4th? Nothing cancels, so you just have to write it all out. X,
X z to the 4th over y.
x, z to the 4th over y. Everybody good? This is pretty straightforward here. And finally, for that last one. Okay, go across on your paper. They all have numbers in front, so go ahead and put them with the exponents. Here, so tell me what to write down. All the numbers in front are going to go to the exponent. Carson, what's this?
Log r to the base 5th to the base a
Plus?
plus log of t to the 1/4 base a
Minus?
log w squared to the base a
Watch this. Minus?
log k3 squared to the base a. Here, what's
Here, now watch. Watch. This is the sum of logs, so isn't this going to be the log of this times this? But then it's minus this one and minus this one. So where are those two things actually going to end up? Because they're both subtract. You can go right to the answer in one step right now. This is the sum, so it's this one times this one, but because this is subtract this one, where are those two things actually going to end up? How?
The denominator.
In the denominator. So the single logarithm here is the log to the base a of, give it to me. They're all there. It'll be a big fraction. What's it going to be? Spread it out, Dave.
log of r to the 5th T to the 1/4 over W squared K to the 3/2 to the base of A.
So look at all these checked answers. They're all single logarithms. Joe?
Would there ever be an answer where you get a negative exponent?
I
Like,
suppose
would
that.
Would that be like negative to the negative? You know what I mean? You have a negative.
If you do, when you write your final answer, move them.
Yeah, but like, what would that look like before? So it'd be like minus 2 log.
Wait, where are you asking me where the negative is?
Then the exponent from W is negative 2. The line before that would be minus negative 2 log W log to the W.
Right here?
Yeah.
And you're asking if what?
If the W's exponent was negative 2 instead of positive 2.
Well, it actually wouldn't do. Because if this is minus, you just brought the minus sign down. It's not gonna be negative.
It'll never be negative.
No. Okay, go to page 686, everybody.